So today we are looking at topic number one, and topic number one, basically we are looking at equations, we are looking at functions, equations and functions. Now, when we talk of the equations, so from the word equal, we are going to be having two parts of an equation. If, for example, somebody gives you something like this, 5x plus 2y equals what here? Equals 10. So you can see we have got two parts here. We have 5x here plus 2y. This is the first part, being equal to what here? Somebody being equal to 10. Equations, equal, the word equal, very, very important like that. So the most important thing that you're supposed to know, ladies and gentlemen, is that an equation, or basically a function is a mathematical expression, dependent, and independent variables, with the dependent and what we shall be calling what here? Independent variables. If, for example, you are given a function like this, y equals, say, 5x plus who? Y equals 5x plus 20. Can somebody tell me, from this expression, which one will be the dependent variable? 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 Somebody talked to me this morning. Which one will be the dependent variable? Which one will be the dependent variable? Which one? So in this case, as I wait for you guys to type, no dependent, it is y that is depending on x. It is y which is dependent on x. Such that if you tell me that x in this case here equals 1, then I will easily give you the value of y. So y in this context here will be 5 times x, which is 1, plus 20. I'm simply trying to fix x here. So y will be 5x, which will be 5 times my 1 here, x now is 1, plus 20, which gives me 20 what here? Which gives me 25, So I can see in this case here that x is the predictor variable. By knowing x, I will be able to know the value of y, because y simply responds. I'm repeating again here that x in this case here is the predictor, variable. Predictor variable is what we also call the independent, variable. And then we have now y here, which we are calling a response variable, or a dependent variable. Basically, y is responding to what here? Somebody is responding to x. Now, as we dive further into this concept of predictor and response variables, there is something that I would want you guys to appreciate. If, for example, somebody was to give you two variables in this case here, which are those phenomena which keeps on changing, taking different values. So in this case here, for example, if you are given here advertising amount versus sales, are the two variables. Yes, they are variables, they're never fixed. Advertising amount will keep on doing what you're changing. And as the advertising amount changes, of course, we know that sales will respond. But now I would want you guys to really talk to me this morning between these two. Which one is the dependent variable? Which one is if you have to put them in an equation, if you have to put this in an equation, if you have to put this in a function, which one is the dependent variable? Which one in this case here is the dependent variable? Which one is a dependent variable? The one that depends on the others, George is telling us, is sales, which depends on advertising. Because the more you advertise, the more we expect sales to respond. It can never be the other way around. So sales becomes dependent on the response variable, and then sales or the advertising amount becomes the predictor. It is the one that will help us predict what here, predict this, will help us predict this. All right. How about this one, ladies and gentlemen? How about this one here? We have here something very nice here. We have, for example, output of maize. Output of maize. Output of maize versus amount of rainfall. Amount of rainfall, of course, keeps on varying every day. Whenever you have got rainfall, you can't have rainfall like 10 millimeters this year and then 10 millimeters next year. No, it will keep on fluctuating. There'll be good years, there'll be bad years in terms of rainfall. All right. So when you look at these two variables, can somebody talk to me this morning? Which one in this case is the dependent? Which one is the dependent variable? Which one is a dependent variable? Which one is a dependent variable? Which one is a dependent variable? Maize, I'm being told here, is dependent. Maize, I'm being told here, is dependent. Maize, I'm being told here that maize is what here is dependent. Yes. Rainfall is independent because rainfall basically it's an act of God. It's only God in this case who can mention to us like this. I'm going to give you this amount of rainfall. It is we as human beings, of course, we cannot influence rainfall. We cannot influence rainfall directly. Now, ladies and gentlemen, I would want us to discuss something very important here. I would want us to discuss here what we call the polynomial. The polynomial functions. The polynomial functions. Polynomial functions. Polynomial functions. And I would want us to start straight away with what we call first degree polynomial. First degree polynomial functions. First degree polynomial functions. First degree polynomial functions. So this will be the first one, first degree polynomial functions. So these are functions. These are functions whose highest power of the independent variable, whose highest power of the independent variable is 1. All those functions whose highest power of the independent variable is 1, they are called first degree polynomial functions. First degree polynomial functions. First degree polynomial functions. They are also known as linear functions. They are also known as linear functions. Into brackets here, straight lines. Into bracket, straight line functions. Straight line functions. Straight line functions. So remember, in high school, you used to tell us that for straight line functions, y was equal to who? I want to see whether there is anybody who is able to remember these. Y was equal to who in high school? Straight line functions. Y was equal to who? Y was equal to who? Is there somebody who is able to remember this? In high school, y equals who? Y equals who? Mx plus c. Thank you very much. Mx plus c. Mx plus c. Mx plus c. If you look at this function very well, this x is the independent. And since it is the independent, you can see x is raised to power 1. X is raised to power 1. X is raised to power 1. So there is an implied 1 there, for the independent variable. So automatically then becomes a first degree polynomial function. Here in college, we shall not be looking at this item this way. For us, ladies and gentlemen, our y will always be equal to a plus bx. This is what I would want you to take down. This is how we shall be representing our polynomial functions. This is how we shall be representing our polynomial function. Polynomial. Poly means many, many, many. Poly, like that. So then we have in this case here our example of the first degree polynomial function will be y equals a plus bx, like that. Y will be equal to a plus bx. Where from, of course, high school, you can see this a is alone. So this a is what we shall be calling the constant. This a is what we shall also be calling, this a is what we shall also be calling the y-intercept. The y-intercept. The y-intercept is what we shall also be calling the y-intercept. And then we have our b. B in this case here is the gradient. B is the gradient. B is the gradient. B is the gradient. The gradient or the slope like that, or the slope like that. Great. So, ladies and gentlemen, I would want you to appreciate one thing here. For first degree polynomial functions, what do we need? For first degree polynomial functions, what do we need? For first degree polynomial functions, what do we need? Listen and listen to me very well. To define a first degree. To define a first degree polynomial function. To define a first degree polynomial function, we need at least 2 points. We need at least 2 points through which the function passes. Through which the function does what here? Through which the function passes. To define a first degree polynomial function, we need at least 2 points through which the function passes. So if, for example, you are given point A, which is 3, 5, and then you are given point B, which in this case here, for example, is 6, 8, like that, 6, 8, like that, 2 points at least, 2 points must be given. And then you are told in this case here, a linear function passes through or define a linear function, define a linear function that passes through points A and B, that passes through points A and B. Define a linear function that passes through points A and B. Define a linear function that passes through points A and who? Points A and B. Define a linear function that passes through points A and B, like that. The key word is, they have mentioned the word linear. But before, ladies and gentlemen, I even go to tackling this question, I would want to pause a little and ask you guys, when you have a point like this, A, 3, 5, these three, in terms of the Cartesian plane, these three, the first number given here will be your X. The second number will be your Y. That's how, in this case here, they're denoted. So we have X vis-a-vis who? Vis-a-vis Y. So define a linear function that passes through points A and B. And those points, ladies and gentlemen, of course, they are given here, 2 of them. So then I will tackle this question this way. This is what I would recommend. There are very many ways of solving this question, but this is what I shall recommend. This is what I shall recommend. Ladies and gentlemen, this is what I shall recommend. So we have the solution. So I write the first thing that I will do here is to write the presentation. So we know if it's a linear function, it's a first degree polynomial. This is the general form. Y equals a plus bx. From there, I will form two simultaneous equations. I will start with the first point and form the first equation by basically plugging in x and y here. So we have y is 5, I'm following this, which will be equal to a that I do not know, plus b here times x, and x is 3. So you see, I can't say b3, it will be what here, somebody will be 3b. In mathematics, you must start with the number. So then we have this is equation number 1. You go ahead and now form equation number 2 by making use of point b. You go and give us the second equation by making use of point b. So point b, what do we have? Y is 8. Y is 8. In point b, y is 8. I'm plugging them in here. I do not know what a is. Plus, in this case here, we have a bx and x is 6. So b6. So this gives me 6 boy. 6 boy. So then could you kindly go ahead and subtract for us? We want to eliminate a. We want to eliminate a. So to eliminate a, go ahead and subtract. So 5 minus 3. This gives me 5 minus 8. 5 minus 8, this gives me minus 3. Equals a, and a disappears. That was our objective, to kill a. And then we have here 3 minus 6. So 3 minus 6, this gives me minus 3 boy. Then who can go ahead and give me the value of boy? So now can you see from the equality? From the equality, minus 3 equals minus 3 boy. Therefore, the boy will be equal to minus 3 over minus 3, which will end up giving me 1. Thank you so much. Thank you so much. So up to here, are we together? 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 Thank you so much. Thank you so much. Thank you so much. Thank you so much. So in this case here, b equals 1, like that. B equals 1. Now, having gotten the value of b, we can easily get the value of a by substitution. We can easily get the value of a by substitution. Then how would we substitute here? What I'll come and do is to ask myself, what is the value of a from equation 1? What is the value of a from equation 1? So from equation 1, we have here 5 equals a plus 3 times boy. Fortunately, we know the value of boy. Fortunately, we know the value of boy now. So the value of boy here is 1. So then we have here 5 equals a plus 3. So once I have here 5 equals a plus 3, then this 3 is a constant which has to be taken to the other side. So this 3 has to cross over. When it crosses over, the life can never be the same again. So we expect when this 3 crosses over, we expect the sign to change. So basically here it's a positive. When it passes over to the other side of the equal, it becomes 5 minus 3 equals a. Therefore, a equals 2. A equals 2. A equals 2. Thank you very much. And then now once I have the value of a and b, I can go ahead and write the first polynomial equation. Now I can go ahead and write the first equation. I'll come and say here, therefore the equation, therefore the equation, therefore the equation. And the equation here is y equals a plus bx. And therefore my y will be equal to a that I happen to be knowing, which is 2 plus b. You see, b is 1, x like that, 1x. But remember in mathematics, if you write it like this, I'll know that this student is not a very aggressive student. This student is not a very aggressive student. Why? Because you see, 1 is supposed to be silent. 1x. 1 is supposed to be silent, a silent partner. Therefore, my y will be equal to 2 plus who? Y will be equal to 2 plus x. Y will be equal to 2 plus who? Y will be equal to 2 plus x. Are we together up to here? Are we together up to here, ladies and gentlemen? Are we together up to here? Are we together up to here? Are we together up to here? Please feel free to ask questions. Feel free to ask questions. Thank you very much. Now, ladies and gentlemen, once I reach here, what I need to do very fast, what I would want to do very fast is to come and show you that, hey, I'm also aware that some of you love this other method. I'm also aware that some of you love this other method. If B is the gradient, remember this B, now will be the gradient. If B is the gradient, I'm quite aware that some of you could be remembering the formula that the gradient is change in y over change in x. Is there anybody who is able to remember this formula? Anybody who is able to remember this formula? Can somebody in this case here talk to us this morning? Is there anybody who is able to remember this formula? Is there anybody who is able to remember this formula? Thank you very much. Thank you very much. Is there anybody who is able to remember this formula? Is there anybody who is able to remember this formula? These guys are not saying yes. These guys are not saying no. And I'm so much aware that most of them came from high school just the other day. They came from high school just the other day. Anyway, I'm joking. But is there anybody who is able to remember this change in y over change in x formula? So remember, this is method number 2. Method number 2 of getting, in this case, the value of b and the value of a. So change in y. So these are our y values. Change means you are subtracting. You can decide to take b minus a or a minus, it doesn't matter really. So change in y, this will be 8 minus 5. All over change in x, which will be 6 minus 3, like that. Because I said here b minus a, the same, change in x, like that. So then this will be 3 over 3, which will end up giving me 1. After that, then now to get the value of a, now I'll come and use the general equation. I know that my y equals a plus bx. Now I've got every other thing. Apart from a, apart from this small a, the y coefficient. So then what I'll do, ladies and gentlemen, here, I will come and pick either a or b and then plug the values here. Any will give me the same answers. So in this case here, we have a, I'll pick a. So we have our y here is 5 equals a that I do not know, plus boy I know boy is 1. And from this point a, I know the value of x is 3. So then this will be 5 equals a plus 3. Therefore, please let this plus 3 cross over. When it crosses over, it becomes minus. So this will be 5 minus 3. So 5 minus 3 equals a. Therefore, a equals 2, like that. A equals 2. A equals 2. And once we have our a being equal to the gentleman, I'll be able to remember here that ultimately they wanted us to define the equation y equals a plus bx. They wanted us to define the equation between the connection between y and x. So that my y here will be equal to a, which is 2, plus boy in this case here, who is 1 there, times x like that, which culminates to y equals 2 plus who? Y equals 2 plus x, like that. Y equals 2 plus x. So are we together really up to there? Are we together up to here really? You guys are not talking to me. I don't know why. They're not talking to me. I don't know why. They're not talking to me. I don't know why. Are they able to follow really? Are they able to follow? Thank you so much, George. Thank you so much. Thank you so much. Now, in this first degree polynomial functions, your syllabus requires us to teach you guys how to solve simultaneous equations whose order is of first degree polynomial. So if, for example, ladies and gentlemen, you are given here as an exercise, if you're given here, for example, 2x plus 3y, so we have here 4 plus 9, giving me 13. And then you're given, for example, 3x minus 2y, 3x minus 2y. Let me make this one 3x minus just y, like that. 3x minus y. So 3x, that gives me 6 there. 6 minus 3. So that gives me 3. So if you're given something like this, these are two equations simultaneous. These are two equations. These two equations, you're supposed to use them at the same time to be able to get the value of x and y. So solve for x and y simultaneously. Solve for x and y simultaneously. So if you tell me to solve for x and y simultaneously here, there are so many methods I could make use of. I could, for example, decide to use matrices. I could decide in this case here to use matrices. All right. I could decide in this case here to have the values of x being the same. And then I eliminate. I can use elimination method. All right. So I would want us to use the elimination method. So to use the elimination method, you look at your equations very well. You know, this is equation number 1. This is equation number 1, this is equation number 2. So you look at your equations very well. As you look at them, you identify the variable which is easiest for you to have a common denominator. Like you see here, we have 3y and this 1y. So 3 and 1. So the LCM there, of course, is 3. Or rather, what I will do, ladies and gentlemen, here, I would want equation number 2 to have 3 here instead of 1. So then to solve this simultaneously, equation number 1 is going to remain. Equation number 1 is going to remain. And then now we have this equation number 1. But equation number 2 will be multiplied with 3 to make this one 3 as well. So and remember, when I'm multiplying equation 2 with 3, then it will be everything being multiplied by 3. Everything being multiplied by 3. What do we have here? We have 9x minus 3y equals what at the end of the day? I'm multiplying everything, cross-cutting, multiplying everything by 3. So equals on the other side, we have 9. So ladies and gentlemen, once I reach here, I'll be able to eliminate y. Can someone talk to me this morning? How do I get to eliminate y here? To eliminate y, should I add or subtract? I would want y to be killed to 0. How do I kill it to 0? Do I add or do I subtract? Do I add or do I subtract? Do I add or do I subtract? Can someone talk to me this morning? Do I add or do I subtract? Thank you so much, because they are children of different parents in terms of science. In terms of science, they are opposite. So this is plus 3 and this is minus 3. I can only kill this y by adding. You add. Assuming that this was plus and this was plus, to kill y, I would have subtracted. Assuming this was minus 3y. If the signs are the same, you eliminate through subtraction. But whenever the signs are different, you eliminate by adding. So, ladies and gentlemen, then if we were to add here, we shall get 2x plus 9x, giving me 11x. This disappears, which was our, objective. 13 plus 9 gives me 20 what here? Gives me 22. 13 plus 9 gives me 22. Right? And then my x then will be 22 over 11. So 22 over 11 gives me what at the end of the day? 22 over 11 gives me what at the end of the day? Somebody talk to me. That x equals who? X equals 2. X equals 2. And of course, now the moment you give me the value of x, right? And then my x then will be 22 over 11. So 22 over 11 gives me what at the end of the day? 22 over 11 gives me what at the end of the day? Somebody talk to me. That x equals who? X equals 2. X equals 2. And of course, now the moment you give me the value of x, I will very easily give you the value of y. Through substitution. So I'll come and pick any of the equations here. I will come and calculate the value of y from equation 1. The value of y from equation 1 or equation 2, doesn't matter, whichever equation. So value of y from equation 1. So then what do we have here? We have 2x plus 3. Fortunately, we know what x is. Fortunately, we know that x is 2. So 2 times 2, because x is 2, plus 3y equals 13. So then this boils down to 4 plus 3y equals 13. So take this to the other side. It will be 3y equals 13 minus 4. It will be 3y. 13 minus 4 gives me what figure? Somebody, you guys have calculators, and we don't want to reason so much in the morning. Thank you, Brian. So this gives me 9. So therefore, my y will be 9 divided by 3, which will end up giving me what figure there? Which will end up giving me 3. Which will end up giving me 3. Y equals 3. Y equals 3. Y equals 3. Y equals 3. But are we together really up to here, ladies and gentlemen? Are we together really? Are we together? Are we together? Are we together? Are we together? Ah, great. Thank you so much. Thank you so much. Then if you allow me, I will be able to take you straight away to what we call second degree polynomial functions. If you allow me, straight away, I'll be able to take you through what we call second degree polynomial functions. What we call second degree polynomial functions. Second degree. So we have what we call second degree polynomial functions. Functions whose highest power. Functions whose highest power of x, what I call independent variable. Independent variable. What I call the independent variable, whose highest power of x is 2. Whose highest power of x is 2. Functions whose highest power of x is 2. They are also known as quadratic functions. 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 Their general form is y equals a plus bx plus b1x plus b2x squared, like that. Any function whose x, highest value of x, is squared. Remember, for you at your level here, y, the dependent can only be raised to 1. All right. So if you're given this kind of a function, ladies and gentlemen, then automatically you should be able to know that this is what here, a second degree polynomial. Poly means many terms. Poly, many terms. A second degree polynomial function. 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 Great. Great. So, ladies and gentlemen, once you really have this, you would want to see examples. So, for example, if you're given here y equals, we have here something like, say, 10 plus 5x plus, for example, 20x squared. Then this becomes a very good example of a quadratic function. A quadratic function. All right. Now, ladies and gentlemen, please listen and listen to me very well. Listen and listen to me very well. In your exams, I'll be able to show you from your past papers. I'll be able to show you from your past papers. I'll be able to show you from your past papers. I will be able to show you this from your past papers. If, for example, somebody will give you something like this. So you're given something like, say, 100 plus 3x, all right? All right, yes, plus, say, 2x squared equals 0, Then how, this is an equality. So they would want you to go ahead and solve for what here, somebody? For x. They would want you to go ahead and solve for x. Okay, so allow me to make this 100 negative 100 right there, negative 100. So go ahead and solve for x. It's a quadratic equation. It's a polynomial function. It's a polynomial function. It's a polynomial function. So is there somebody who is able to remind us how this quadratic formula, is there anybody who is able to remember how the quadratic formula looks like? Anybody who is able to remember how the quadratic formula looks like? Is there anybody who is able to remember how the quadratic formula looks like? Let's talk business. Aha, tell us, what do we have in the numerator? What do we have in the numerator? So in this case, if it's a quadratic formula, we have x being equal to, let me see just a moment. I can see I have geniuses around. So x will be equal to who? X will be equal to who? X will be equal to who? Like Yusuf tells us, minus b, plus or minus. And then what follows after? Plus square root. Thank you very much. There is a square root. There's a square root. Thank you so much. How about inside? The very important formula. Very important formula. Very important formula. Minus b, plus or minus. And then we have something inside here. Aha. Thank you so much, Yusufu. B squared minus b squared minus who? Minus 4ac. Thank you so much. And then everything to be divided by who? 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 Everything to be divided by 2a. 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 So, and then now you will be forced to remember something very important. That if that is the case, then can somebody give me what is the value of a from this? From this. A is the natural partner of x squared. A is the partner. A is the partner. The number that comes before x squared is 2. B is the number that comes before x. The number that comes before x is what, yes, somebody? 3. C is the constant term. The constant term, which in this particular case is minus who? The constant term, which in this particular case is minus 100. Minus 100. So then could you kindly do me a favor? Is it possible for you to go ahead and plug in these things there? Please go ahead and plug in these things there. Then our x will be equal to minus boy. So minus 3 plus or minus the square root. Plus or minus boy. So boy is here. So the most important thing, whenever you hear of quadratic equation, it is ax squared plus bx plus c equals who? 0. That's how the quadratic formula looks like. And the a is the number that comes before x squared. A is a number, you don't have to rearrange this really. I've seen so many students trying to rearrange. No, so long as I'm a bright guy, I know x, A is the one that comes before x squared. So A is 2. B is the number that comes before x, which is 3. And then we have C, which is the cow, which will be minus what here now? Minus 100. Minus 100. So then we come here. So B squared, so 3 squared gives me 9. Minus 4 times A, which is 2. Times C, which is negative 100. And then everything will be divided by 2 times A, 2 times 2, 2 times 2 like that, 2 times 2 like that. Great. Thank you so much. So my x, ladies and gentlemen, here will be equal to minus 3 plus or minus. Can you kindly give me this figure that we have in the square root, under the square root? Go there with your calculator. Say 9 minus 4 times 2 times minus 100. Say 9 minus 4 times 2 times minus 100. What are we getting there, somebody? 9 minus 4 times 2 times, somebody's giving me 809. 809. 809. 809. All over 2 times 2. 2 times 2 is 4. Then we move slowly. Our x will be equal to minus 3 plus or minus. Could you kindly give me this square root of 809? in 2 decimal places. Square root of 8 or 9 in 2 decimal places. Square root of 8 or 9 in 2 decimal places. In 2 decimal places. Is there somebody who has a good calculator there? 28.44. So we have here 28.44. Everything to be divided by 4. 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 Thank you so much. You guys are great people indeed. So I would want you guys to go ahead and do me a favor. I would want you guys to go ahead and do me a favor. Because of this plus and minus, which are at the same position, then you're going to have 2 values of x. The first value of x will be minus 3 plus 28.44. So the first value of x will be, when we consider plus alone, divide this by who? By 4. The first value of x will be, could you kindly take this minus 3 plus this, will give me 25. 25.44 all over 4. So then could you kindly give me this figure? 25.44 all over 4 will end up giving me what figure? Abracadabra. What figure? Abracadabra. What figure? Abracadabra. So they're telling me it is 6.36. It is 6.36, like that. And then the second value of x here will be when we have a minus sign alone, which will be minus 3 minus 28.44 all over 4, which will end up giving me what figure? Somebody? Minus 3 minus 28.44 minus 3 minus 28.44. Minus 31.44. You guys are geniuses. Thank you so much. All over 4. Then at the end of the day, what figure are we getting for our x2? According to this gentleman, minus 7.86, like that. Minus 7.86. Minus 7.86. So, ladies and gentlemen, this brings us to the end of our first session. And I would want to take this opportunity to welcome all of you to RCM Online College. Right? So if you are interested in our programs, as somebody has hinted to you there, you should be able to call our number. 555,000 or 0719 525,000, like that. Of course, we give very affordable programs, and of course, of high quality. So I don't know whether there is anybody here who, like now, I will be able to connect you to our learning management system. We have a learning management system, which I'll be able to connect you. All of you guys will be paying us, of course. I'll be able to connect you to the learning management system where, for example, after I've given you this indicator, I've been able to introduce you, right, to this particular topic like this. So I expect you to go and watch like 5 videos for topic number 1 in that learning management system. It has got notes and videos, and you're able to gauge yourself. I mean, it has got even quizzes, questions, answers. You are able to evaluate yourself like that. So when I come now next time, I don't have to keep on like now saying again, like 3rd degree polynomial. You'll tell me, Mwalimu, no, that one we are okay, because we're able to watch all those videos in our learning management system. Videos over there are very clear. All right. Thank you so much. I look forward to having you guys as my best friends around, because we shall be able to bring your friends as well to this particular class. I'm looking forward to seeing you tomorrow again.